Hello everybody, welcome back to our FAQ program. FAQ stands for Frequently Asked Questions. Here we will satisfy your curiosity about decentralized blockchain technology. For starters, let me begin by saying, if you get confused by some terminologies in the decentralized blockchain technology, that is because the technology borrows lots of terminologies from other industries or even everyday life. But when used in the blockchain context, these jargons take a completely different meaning. For instance, the term mining. It's borrowed from the extractive industry, of course, but mining a block doesn't mean the same thing as going to the coal mines to excavate some precious rocks from there. We will talk about mining in an FAQ episode which will follow this one, so stay tuned. But I digress. Here we will not talk about mining. We will talk about a blockchain terminology which causes more confusion because it's borrowed from our everyday life activities, especially ones having to do with documents and certificates. So it's called digital signatures. Yes, of course. In the beginning, I also thought that digital signatures meant the handwritten signatures you drew with a digital stylus to sign a digital document. But in actuality, in the blockchain context, the term digital signature doesn't have anything to do with handwritten human signatures at all. So what is it? Handwritten signatures have been used to authenticate and verify the flow of documents, certificates, goods, and services since the 17th century. The handwritten signatures have also been used to guarantee the legal strength of human contracts. Within the blockchain context, the digital signatures also seek to guarantee the authenticity and validity of transactions and documents flowing over the peer-to-peer network app infrastructure. Except that the digital signatures on blockchain are not drawn by human hands. So, in blockchain technology, digital signatures refer to a cryptographic key used to link a particular identity to a particular message. When these two things match, that means a transaction or document is valid and original. Each document and transaction in the decentralized blockchain technology uses its own unique cryptographic key or digital signature, which will be verified using number theory, a kind of a mathematical operation each time the document needs to be assessed or a transaction needs to be conducted. The digital signatures are also safeguarded using a double bind method with both a public and private key, which form a pair. The public key is the owner's identity, while the private key is a secret information which can only be accessed by the owner. So, as an illustration, let's say I would like to send you a document over the peer-to-peer network. I will send an encrypted message to you and your public key is available for everyone to see. Then I can simply use your public key in the algorithm which encrypts my message. Observers may be able to see or intercept the encrypted message. They, however, will not be able to decrypt the message unless they have your private key, an information which only you have access to. Thus, I can ensure you are the only user that can see the original message without personally requiring your private key. This way, digital signatures can circumvent the privacy issue in the peer-to-peer network, whereby data and information are distributed over the network members, while ensuring that only deserving parties can access this data and information. Furthermore, digital signatures also reverse the operations of the keys. So, I can use my private key in the signing algorithm to create a signature linked to my message and public key. No party can derive my private key or forge valid signature for me with just my signature and public key. However, anyone who knows my public key can easily verify that the message is signed by my private key. As you can see, digital signatures play an essential role in document sharing activities over the blockchain. Thanks to the basic authenticity and privacy functions they provide, illustrated by my explanation of document sharing earlier, they are primarily used to verify the authenticity of transactions. When users submit transactions, they must prove to every node in the system that they are authorized to spend these funds, while preventing other users from also spending those funds. Every node in the network will verify the conditions of the submitted transaction and check all other nodes work to agree on a correct state. If I want to send 1 Bitcoin to Bob, I must sign a transaction spending 1 Bitcoin of inputs using my private key and send it to the nodes on the network. The miners on the network have knowledge of my public key and thus will check the conditions of the transaction and validate the authenticity of the signature. Once validity is confirmed, the block containing that transaction will be then ready for finalization by a validator or miner. Okay, so now you get a sense of what digital signatures in blockchain are like and what functions they perform. As you can easily tell from my earlier explanation that they work in a way much more complicated than the human handwritten signatures. So because they are so complicated and safeguarded by mathematical operations tied to computational algorithm, it will be much harder to forge or falsify them. That's all for our FAQ program today. Hopefully the long explanation doesn't give you any headache. So in the next episode, we will talk about block mining, so stay tuned.